The Shinjuku Business Park in Tokyo reflects modern Japan and supports Japan's economy as a key business hub. Beneath these high-rise buildings is a huge pipe about 8 kilometers in length. This pipe's destination is a massive heating and cooling center. Chilled water and steam are supplied to these buildings from this single facility. A new type of chiller system developed by Hitachi with one of the world's largest refrigeration capacities is in operation here. This environmentally conscious district heating and cooling system utilizes energy efficiently and controls heating, air conditioning, and hot water supply to the buildings in this district at a single location. The first such system in Japan was installed at the Osaka Exposition of 1970. At that time, Hitachi chillers were employed in this system. After the exposition, Shinjuku underwent redevelopment, and the Shinjuku District Heating and Cooling Center, or Shinjuku DHC Center, was created here to provide cooling and heating from a single location to a group of high-rise buildings. The Hitachi chiller used at the Osaka Exposition was relocated here. In 1991, while constructing the Tokyo Metropolitan Government Office Building, the Shinjuku DHC Center was moved to a new location near the old one and enlarged. Hitachi developed a centrifugal chiller with the largest capacity in the world at that time of 10,000 refrigeration tons, the equivalent of 15,000 home air conditioners. This single chiller was able to supply the entire air conditioning for the Metropolitan Government Office Building. By increasing its total output, it became one of the world's largest. Chief Engineer Yasuo Uraki, who led this development work, looked back on that time.
今作っている機械と大きさも違いますしですね、規模が全然違うということで、あまり身近には見えなくて、伝説的な存在になっているかもしれませんけれども。
In the subsequent 20 years, Hitachi's chillers continued to operate smoothly. However, a new chiller with higher efficiency was needed to respond to the needs of reducing its environmental footprint.
まず一番目には環境負荷低減 COP というのはですね、例えば一次燃料ガスあるいは電気これを1入れたとすると取り出せるエネルギーが今までは 0.75 でありました。それを 0.75 から 0.9 まで上げる、あるいはこれからの更新工事によってそれ以上1以上を目標にしているというところですね。
Now let's look at how the chiller cools the buildings. The chiller is made up of 3 sections: evaporator, condenser, and compressor. The liquid refrigerant is vaporized to gas in the evaporator. The latent heat of the evaporation absorbs the heat from the chilled water flowing through the evaporator tubes. If 12 degrees Celsius chilled water is supplied from the return piping, this is chilled down to 4 degrees Celsius. This chilled water is supplied to the buildings to cool down rooms, while the chilled water absorbs the heat from the room and is heated to 12 degrees Celsius again and returned to the chiller. The evaporated gas refrigerant is sucked into the compressor and discharged to the condenser. The refrigerant is cooled down and condensed here and returned to the evaporator. This cycle is repeated continuously, and the chiller supplies a pleasant airflow to building occupants. Hitachi Appliances received an order for the development and manufacture of new chillers. The original 2 sets of 7,000 refrigeration tons will be replaced by 4 sets of 5,000 refrigeration tons units. Yasuo Uraki, who was in charge of the original chiller development 20 years ago, also led the development this time.
この次必ずリプレイするときは必ず自分自身の手でですね、注文をいただいてリプレイスしたいなというふうにずっと思っていました。
The customer's requirement this time was for improved chiller efficiency. Moreover, the chiller should be highly efficient not only in the summer season when the chilling load is large, but also in other seasons when the load is smaller. Senior engineer Yasushi Nakamura led the design of the chiller. He was also in charge of maintenance work at Shinjuku DHC Center when he joined Hitachi. So he is strongly motivated to develop the new chiller.
その物の大きさとその蒸気タービンで駆動するというその技術力というのに非常に感動した記憶があります。で、いつか自分もそういった仕事に携わりたいなという思いを抱きました。
The first answer the project team and Nakamura came up with was to re-examine the heat exchanger layout in the chiller. The division of the heat exchangers into two sections improved the efficiency of the chiller by reducing the temperature difference between the chilled water and the cooling water. This is realized through the counterflow of chilled water from 12 degrees Celsius to 4 degrees Celsius in the evaporator and cooling water from 32 degrees Celsius to 38 degrees Celsius in the condenser, thus reducing compressor power consumption by 8%. However, this would not achieve the target when the load was less. Therefore, they separated the chiller into two units, as with the heat exchanger, so that only one unit would be used during low load times.
小さい冷凍容量になった時にですね、2台で運転するよりも1台止めて1台で運転する方が効率が良くなりますので、そういったメリットもございます。
Nakamura set out to achieve even greater efficiency, and he asked for advice from Uraki, who had developed the largest class chiller in the world.
ハネグインペラとですね、それからディフューザーという性能を支配する分がございますけれども、最適な性能をシミュレーションするということで、その点いろいろ中村主任技師ともですね、技術的にいろいろ議論をして、やってきております。
Based upon this advice, the diffuser angle was calculated so that the refrigerant gas of the compressor was discharged to the three-dimensional impeller in the most efficient manner. This extensive trial and error process resulted in an ideal compressor where the refrigerant gas was efficiently discharged to reduce flow friction loss and remove air bubbles. Moreover, compatibility with the inverter control was also verified. By re-evaluating all the functions of the chiller, it achieved a higher efficiency target level and the number one unit was completed. Manufacture of the remaining chiller went ahead at full speed. Transportation of the completed chiller commenced. The chiller was split up into sections, loaded on trucks, and departed from the Tsuchiura air conditioning works. The hatch used to offload the 10,000 refrigeration tons chiller on the previous occasion was reopened after an interval of 20 years. The chiller was offloaded from the truck by a crane and lowered down through the hatch. The chiller arrived at the underground level. Then, reassembly and installation work commenced. July 2013. As the summer season approached, installation of the new chiller beneath the high-rise buildings of Shinjuku was completed. The chiller commenced actual operation. The target performance levels were achieved, and all concerned felt great relief.
お互いにですね、その技術面で協力し合いながらですね、電動ターボもまた35年後リプレイスがある時に能力が下がらなかったということを話せるような、オペレーションあるいはメンテナンスを続けていけるように。
This renewal has resulted in a much higher level of efficiency at the Shinjuku DHC Center. The development team anticipates that this project will lead to more advances in Hitachi chillers.
今都市の中で、エネルギーを効率的に利用するというようなことで、スマートエネルギーネットワークというのは提唱されておりますけど、熱を供給するものとそれから電力を供給するシステムを一緒に持つことによってですね、トータルでエネルギー効率を上げていくということがですね、一つの大きな方向性だと思っておりまして、今回のシステムでですね得た技術をですねそちらの方に展開してですね、さらに社会に貢献できるようにしていきたいなというふうに考えております。
私が初めて新宿司令さんに行った時にその抱いた感動というか、そういったものをですね我々の後輩にもですね同じような感動を持ってもらって、自分もそういう仕事がしたいという思いを持っていただもらえれば嬉しいなと思います。
Hitachi chillers are in operation worldwide. Behind the scenes are the development and design know-how and the spirit of excellence in manufacturing passed on from the older to the younger generations. Deep beneath the high-rise buildings of Shinjuku, their enthusiasm and dedication toward excellence in manufacturing continuously supports the comfortable life of the people working there.